Hello, everyone, and welcome to episode 44 of Nutanix Weekly. I'm your host, Andy Whiteside. As some of you guys know from listening, we don't do a lot of spruce it up a lot, not a lot of intro music, exit music. So Harvey's decided he would sing something for us. Go ahead, Harvey.
Twinkle, twinkle, little star.
Okay, good enough. Twinkle, twinkle, little star. All right, sorry, I put Harvey on the spot. Thought I'd lighten the mood on a Monday. Harvey's with us. Harvey Green, director of all kinds of things, solutions architect at XenTegra, now director at XenTegra Gov. Harvey, you changing the world this week?
I am doing my best. It's still early. It's still Monday.
Well, Jira, he has a whole new version of AOS that he released. So he's doing his part.
Oh yeah, I was very busy all weekend. Yeah, finally got around to it.
So that's the voice of Jira. Jira, you guys have a new guy, friend of ours, starting at Nutanix here in a few weeks, and he asked me what he needed to know. I was like, just know Jira. Just make sure you know who Jira is. That's all you need to know.
Not exactly scalable advice there, but appreciate the compliment nonetheless.
Yeah, well, it's true. Very, very valuable resource. Lucky to have you on our podcast here.
Happy to be here. Thanks for hosting.
So I said episode 44, right? I didn't get that wrong. So episode 44, we're going to cover this blog from February 24th, introducing Acropolis operating system, acronym AOS. I'm a big fan of translating acronyms into their actual names so that people don't get lost. 6.1, which is 6.1. Make sure everybody's clear on that.
I think yeah, if you aren't familiar with dots.
What is happening?
Why don't we call this Acropolis operating system 2202? You know, for the new naming convention everybody's using. You guys are still doing numbers. At what point do you hit this plateau and the numbers don't make sense anymore and you're not doing Acropolis 99.8 like it's a radio station?
Actually, the future's here. It's just not evenly distributed, right? Actually, PC is on the 2202 bandwagon. So
okay.
I don't know. Maybe AOS gets there one day. Maybe it doesn't. Maybe it stays a rebel.
Well, so somewhat on topic, and we're going to jump into AHV here in a second, but Nutanix is full of acronyms. Give us your top 10 off the top of your head, on the spot.
Oh man, we shipped like 5 new ones like last week alone. We got like the NDBs and the NCIs and the
That's right.
NUSs and all kinds of good stuff. We got, and of course you got all the oldies but goodies, AOSs and CVMs.
Whose fault is that? Is that the technical guys that like acronyms, or is that the marketing guys? Or who does the acronym madness to us? Because I can tell you,
madness.
I'm not a newbie, but I have lots of newbies that come into XenTegra, and watching them just eyes roll back in their heads with all the acronyms. They have no idea what any of them means. It's kind of a little bit of a problem in our industry.
It definitely is industry wide, right? The TLAs, the 3-letter acronyms.
Yeah. Is it because people don't know what they stand for? Or is it because people just like to be cool and use the acronyms?
Tradition mostly, I'd guess.
Yeah. We're just trying to get to shortcuts. Anyway, I don't know. I'm going down.
I don't get pulled into those meetings.
Well, so what we're talking about today is the Nutanix operating system, Acropolis operating system, AOS 6.1. I think I've said that multiple times now. It's new. What was the previous release?
6.0.
6.0. So we're looking at an incremental change here based on that nomenclature.
Yeah, it's the second STS short-term support release in this train.
Yeah, I'd love to know, who do you think decides whether it's when it becomes a new whole number, the technical guys or the marketing guys?
Both. I don't know. More meetings that I'm not in.
Yeah. Well, I don't know if you use a Mac or not. Use a Mac or Windows?
I use a couple of Macs. Yeah.
Yeah. No Windows?
I remote into a Windows computer.
Yeah. Windows 10 or Windows?
It is Windows 10. Yep.
Yeah. I mean, that's a great example of no more operating systems. We had to just have a new one come out every month. And then all of a sudden the marketing guys say, hey, I think it's time for a new one. And here comes a new one.
Yeah. Right. And then somebody can go like, oh, it's Windows 11 versus, Mac OS. Actually, they just
Windows 10 is the last version of Windows you'll ever have and you'll ever need. There'll never be another one.
Yeah, they're
Wait.
both keeping up with each other now. They're both on 11.
I'm not gonna lie, I thought Vista was gonna be the top.
Ooh. No,
Vista
Vista was at
got
the
some
bottom.
short. This is what people tune in for, right? Is to hear our commentary about what a 15-year-old OS. They probably never actually ran as their daily driver, but no, Vista definitely got the short end of the stick there. Like, it was unfairly maligned.
Yeah. Well, Windows ME might have got it worse.
Windows ME deserved it.
All right, so Acropolis operating system 6.1 incremental release. Gyro, does the intro in this blog have anything of relevance to it that kind of tips its hat to why 6.1 came about, or we're going to find that here in a minute when we can start going through it?
I think it's a pretty awesome, pretty well-rounded release. I'll say just to agree with the intro, right? Making on-prem and hybrid clouds everywhere just better overall.
Yeah, like I was saying, I have a new guy that's going to be working with you guys, I believe, and he was trying to understand from the interview process, is Nutanix software for the cloud or on premises? Because it sounds like it's just cloud. And, obviously that's where your company wants people to go and they want to go with you. At the same time, it's one heck of a cloud software that enables on premises and transitions into the cloud or vice versa, right? Back and forth.
It's software for wherever your cloud is.
That's right. Define cloud, or better yet, define clouds. Then we can have that conversation.
Yep.
All right. So section 1 talks about the memory, or the first non-introductory section, memory overcommit for AHV, which stands for Acropolis Hypervisor. Tell me where that didn't work before, or where that was short before, and what you guys have done now.
Sure. Yeah. Basically, before it was all memory was one-to-one assigned, locked, right? So if you promised a VM 8 gigs memory, then we had to go find it on a host somewhere and allocate it for just that VM's use. So it wasn't overcommitted, wasn't shared. With this now, you can promise more memory to your virtual machines than they actually have present on the hosts in the cluster, right? So something you can be able to do on other hypervisors for a while. We're bringing it now to AHV as well, with those exact same design considerations that have always existed elsewhere. Of, if you promise too much and then use too much, we can't make more memory for free. That's a hardware defined limit, not a software defined limit. So use with consideration, use carefully, but it's fantastic for like lab environments, development environments where, you need to be able to spin up, hundreds of VMs, and the usage within those VMs is very dynamic. I had one customer years ago who at every night at midnight just powered off all their dev VMs. And if you didn't come into work the next day, if you were off that day, then your VMs didn't take up any resources, right? You just powered them on when you got your coffee in the morning. Yeah. So those kind of environments, right, where you aren't particularly picky about performance for any one single VM, you just want, to let everybody see what needs to be seen at the OS level. Absolutely great feature.
So let me highlight something that you said there, and do that by highlighting something you didn't say there. You said dev and you said test, but you did not say prod. Why?
It's totally up to the customer, right? It's what are your requirements for your environment. Personally, what I coach my customers is, something to turn on for prod day one, maybe not, right? Which is why we've taken a very cautious approach to even, developing it, shipping it. AHV is what, 7 years old now, 8 years old now. Because as soon as you overcommit memory, then you have an opportunity for over demand of memory. Yes. And you have to get into interesting, fun things like paging and other fun behaviors, right? That, guess what, are just not even something you have to worry about without memory overcommit enabled.
So I'll have to tell you this. One of the, I guess I will call it a safety. One of the safeties that I always was happy that Nutanix had was this one, where you could not just go out there and overcommit your memory by 2 to 1, 3 to 1. And so I like that this is in there, and I also don't like that this is in there.
I'm with you. I'm totally with you, Harvey, and that's why it's a customer by customer, environment by environment choice to opt in. I'm with you. If it was my environment to run, I probably wouldn't enable it for production. I took a meeting with one customer years ago who they said, without this feature, you'll never, come in our data center, right? In a major way, at least. And we looked at their vCenter and they were running 4-to-1 in production, right? At the hundreds of terabytes of memory scale. And I'm like, well, okay, I can see your point where if you're running this and managing it safely today, then if I say you need to buy 4x as much memory to run AHV, that might be challenging. So, use wisely.
Yes.
So I had forgotten this wasn't in here because we never tell anybody to overcommit, even though I do understand that it may make some sense to some people. Two questions for you guys. One, what do they do in hyperscalers? Do they overcommit you and you don't realize it, or you opt in or opt out? How does it work there? Do we know?
I think I couldn't give you a firm answer.
No.
They probably would tell you, they probably would say it doesn't matter if you can't tell.
Yeah.
Right.
Try
They're
to
managing the risk
mystery.
of what overcommit ratio might exist.
So here's the second part of that question, or the second question, maybe they're tied together. Harvey, if you don't do it in memory, in other words, if you overcommit and it's not able to happen in real physical memory and it has to go somewhere else, where does it go?
Let me make sure I understand the question.
Is it a question or a pop quiz?
So if you overcommit and you run out of physical memory and it has to start paging or traditional paging, so I guess in a normal machine, if it runs out, in this case it thinks it still has it, does the system start doing page swaps for you?
Right. Yeah. Usually that's same thing happens inside the OS, can happen outside the OS. Inside the OS, you'd page into your Windows page file or Linux page, Linux swap partition. And similarly, a VM can page out to, a VM's allocated page file as well.
But if I'm doing that in a system where I'm going to a file and I've got, NVMe or SSD, if it's slow, SSD slow, I'm still pretty darn fast, right?
Perhaps maybe for a certain point of view, but I probably wouldn't agree with that, right? If a VM thinks it's memory and expects memory speed, that your orders of magnitude slower even going to disk there.
Well, and so the other thing that I would bring up is even if I ignore the rest of what's going on, the fact that you are now paging potentially to a physical disk at this point makes you nowhere near as portable as you used to be. And so in the event of a disk failure, a node failure, all of the magic of Nutanix and this, resilient system is no longer, in my eyes, as resistant and as resilient. And maybe they've got some more magic on the back end that I just don't know about yet, but I just don't like the setup.
Well, and also, lastly, there's probably no world where that makes economic sense. If you bought X amount of memory, sorry, that's a harsh answer, but probably true. If you bought X amount of memory and then you fill it all up and you clearly objectively need more, the storage tier there is going to cost you more than buying memory that you clearly need, right? So maybe it's a stopgap emergency method, but in reality, like, you just buy more memory, buy what you need.
Yeah, this is why I both like that it's there and I don't like that it's there.
Time and a place, right? Ironically, given our Venn diagram here of our skill sets, I can picture an EUC environment being actually potentially a great candidate, right? Very, very bursty workloads, lack of very bursty and not a lot of insight into like potentially what's my hour by hour forecasted need, right? So I can make some promises here for the environment in general, paint with a broad brush, and then trust it will all sort itself out.
Well, so here's what I was getting at with all that. I get the way we used to be scared of doing this when we had slower drives or we had less smart architecture, but with the Acropolis operating system controlling the storage layer, I'm less scared of overcommitting than I was back then.
Which I agree with the merits of that. And that's honestly why it makes me even more scared because I could see the potential of somebody, taking that mindset and then overcommitting on purpose to the point that when they do actually need to overcommit, they don't have that as a luxury anymore.
Well, that's why I brought up, I wonder what the hyperscalers do. They don't tell us, do they? And if they
They
I guess
don't.
their point to Jira is like, well, if you can't tell, then you don't need to know.
That's exactly right. And maybe this is the same way. I haven't seen it in action yet. Maybe I'm being overly cautious, but I'll be overly cautious.
It would be neat to be able to go into the hyperscalers and figure it out. That way, for example, XenTegra has Nutanix running in our data centers, and we offer that as a cloud. We could say that if you check this box or sign on this agreement, you never have that happen. You don't have to come check behind us to try and see if you're getting overcommitted or not. It just, here's our agreement. It won't happen.
Yep.
All right, let's go to the topic we all love talking about the most, which is databases. How are we going to make these things scale up in the new Acropolis operating system 6.1?
Yeah, so this is a very exciting enhancement that, in a nutshell, right, we call it kind of vdisk sharding, but basically it lets a virtual disk controller run in a multi-threaded fashion, so we can get multiple paths to get to the same disk. That dramatically, in this release, speeds up the read performances quite a bit. So this, we've said for years, we still say the best way to get performance out of your databases is with multiple disks. It's also in like the SQL and the Oracle best practices, right? Lots of disks and spread your data files across them. First, some people, when they first move to Nutanix, then that's maybe not practical. They can't get the downtime to take this database offline and relay it out onto multiple data files. So we still want to ship enhancements that help them out where they are, right? So help those single large vdisk databases run faster. Yeah. And so that's what this enhancement is doing here, is improving the read performance for that by some really dazzling numbers. We don't want to read bar charts here into audio form, but take a look at it. It's very compelling stuff.
Well, we could use the numbers, the percentage numbers, but let me just explain the visual here in terms of what it does. So we've got our hypervisor. Inside the hypervisor is a control VM. It's our controller. It runs Stargate. Real quick, Jira, 20-second definition of what Stargate is.
Yeah, Stargate is the process by which, a hypervisor, sends IO requests to Nutanix, and then we figure out what node and what disk needs to service all of those. It's Stargate because you can kind of go in anywhere and come out anywhere else.
And then that hands off to the vdisk controller. We're talking a software inside the control VM. I guess we are, based on the
right. So like what part of our code owns like your C drive or your D drive?
Yeah. And then now we're getting down to a single vdisk in parallel reads and writes, or just reads?
This one enhances reads.
Okay. So now, I'm playing devil's advocate. Well, okay. So it's always important, if I'm the storage guy, I want my reads to be right, but I sure as heck want my writes to be right. So what you guys are doing here is you're making the reads a lot faster, maybe as step one to doing this process, getting more performance out of access to that data.
Right. And remember, reads and writes can follow different code paths. So that's why you can see an enhancement that hits one of those and not the other.
Yeah. And then if I go down here to the bar chart, I've got the green bar and now the blue bar, and it looks like on the right-hand side, I'm getting significantly more somethings.
Yes, on the left there, right, the use case, so, single vdisk, right? So if you've moved from like a 3-tier deployment of your database and moved it on to Nutanix without sort of following our best practices, SQL or Oracle best practices, still on a single large vdisk, performance improvement there. But then also on the right side, if you are deploying it according to best practices, even more benefit for you there, right? Because now if you've deployed it across, say, eight disks in the system, those all benefit from the improvement as well. So then you get even more, even faster read enhancement.
Okay. Well, and that just continues to show that Nutanix is serious about getting those naysayers on the database side over to Nutanix.
Yeah.
Let's move on to the next one because I know Harvey didn't really want to talk about the database one that much.
Oh my gosh.
You have any dog in that database fight, Harvey, or are you just going to say, yeah, I ditto?
Yeah, ditto.
Okay. All right, the next one talks about something that sounds extremely interesting: Optane /NVMe tiering. I know NVMe has been a hot topic, at least for me, the last couple of years, because anything fast is good. Anything unbelievably fast is good. Is even better. Jira, what are you guys doing at this piece of the enhancements?
Yeah, I think this first graphic kind of tells a really fun story where it shows, a hard disk drive spinning, magnetic storage, less than 500 IOPS per device, an SSD, maybe call it 20,000 IOPS per device, NVMe SSD 400,000, and Optane maybe 550,000. So all still crazy fast, but there's a little bit of daylight between the NVMe performance and the Optane performance. With this enhancement now, AOS storage can differentiate between those two things. So it used to be they were both just so crazy fast, they would go into one tier together. The tiering them out here now lets us, deliver, say, like Optane tier performance to the very hottest subsets of data, right? Like think back to when we, our first launched with our very tiny SSDs and spinning disks on our hybrid nodes, right? But you can get very, very fast performance out of them because all the hot data went onto the hottest tier of storage on, in that case, SSD. This brings back that same kind of functionality, right? So now if I had a system that had Optane plus NVMe drives, my very hottest data goes onto the very hottest tier of storage.
So spinning hard drives were great back in the day, and then we got to SSD, and then we got to NVMe. Now the fastest thing is Intel Optane.
Yep. Yeah, it's candidly very weird to say you can configure a system where NVMe is the slow tier.
Yeah. Where does the Intel Optane live in regard to the system board?
It looks like a regular disk, right? You'd see it next to your, SSDs. It's still another form of solid state, but that word's kind of diluted, right? It's still another form of storage that would just live in a disk slot.
And I was under the impression NVMe was partially fast because of where it's set in relation to the system board and not having to go through a storage controller. Is the Intel Optane just so fast going through a controller is irrelevant and it's just reads and writes that fast?
My understanding is that both of them are PCI devices, right? So both of them can bypass a controller and they just become PCIe devices.
Okay. Yeah, I mean, what needs that?
I'm sitting here just like shaking my head because all I hear is it went from crazy fast to stupid fast.
That's part of the value prop, right? We want the software to be ready for the hardware and the demands of tomorrow, and evolve to let you, the customer, take advantage of the latest and greatest hardware without changing your management plane, without having to rework the workloads. As the hardware gets better, it's easy to add those kind of nodes to a cluster, move workloads onto it, eject the oldest nodes in the cluster, and get on with your life.
Yeah, I mean, sitting here looking at this chart and it's talking about the latency between the disks too, and it starts out on the left with hard drives at more than 2 milliseconds. Then we get into microseconds, and here we are going from less than 100 microseconds all the way down to 10. So, like, this is, whoo, that's fast.
It is
very fast.
So, Jira, we have a nice diagram, kind of a workflow here on the screen. Why don't you just explain this?
Here's a verbal whiteboard in an audio medium. It shows the right path, right, and how reads can come from lots of places, right? Both persistent storage and whether that's hot or cold tier storage, as well as even the cache that can live within the CVM itself. and then writes go through oplog and then find their way to where they need to live elsewhere in the system as well.
Yeah. This next, there's another bar chart here. It basically just talks about either all NVMe versus NVMe plus Optane. So help me understand this. In the case of NVMe plus Optane, would you be using, which one would be the fast one? Optane, of course, right?
Right. Yeah. Yeah. All NVMe versus NVMe plus an Optane tier. Optane devices are like tiny, right? Think about like 200 gig, 400 gig. You probably can get them bigger than that, but like commonly deployed sizes are they're tiny, but that latency is crazy low, right? So letting the hottest amount of data flow onto those.
How long's Optane been around? Because I thought I was the cool kid talking about NVMe. I didn't know I was dating myself.
I mean, Wikipedia probably would say like 5-6 years, maybe. It's just a guess on my part, but
I would have guessed a couple years.
Takes a while to find stuff for tech to find its way into the data center, right?
Right.
All right, so here's the question: an Optane drive compared to an NVMe, a terabyte. No, I guess you just said, what's the biggest Optane you would find drive?
The ones I feel like I handle commonly in a configurator are like 200 gig, 400 gig.
Okay, so 200 gig versus 200 gig NVMe versus 200 gig SSD, if there is such a thing anymore.
I
mean,
don't.
Give me pricing. Like
I are not a hardware guy. I mean, yeah, Newegg.com. I don't know.
Yeah. Okay. All right. Well, I'm learning a lot here. All right. Next section talks about enhanced business continuity, encrypted DR traffic, improve AOS VSS provider. Let's go with the encrypted DR traffic. That's pretty self-explanatory, but
yeah, maybe some of Harvey's customers over on the Gov side, have stronger preferences around. I want all their application traffic from A to B to be encrypted, and now that's an easy yes, without needing to bring in like another VPN tunnel or doing like switch to switch IPsec.
Yep. So easy enough. Improved AOS. So Acropolis operating system, VSS provider. I feel like I should know what VSS means, but somebody educate me.
That's the volume snapshot service. I might have that a little bit off, but that's basically what it does. Is it lets you, it's how you can do an in-guest quiesce, right? For in-guest data when you're taking a backup. Commonly of stuff like SQL or Outlook back on the day when we ran Outlook on-prem. And so with these enhancements, you can do stuff like incremental backups, or if you have multiple VSS writers, you can target which one you want to have quiesce for the given snapshot.
Yeah, I used to shut all my VMs down, take my backups. That's not appropriate anymore. I don't understand.
Throw the tapes in the trunk, drive to the safe deposit box.
I couldn't take my breaks until the tape backup guy showed up every day. Okay. Harvey, any comments on either one of those?
No, I mean, these are all very, very good things. I like them.
Harvey's a fan.
All right. Next section talks about deeper storage insights. Starts with AES on hybrid clusters. Oh, at least you're nice enough to give us what AES stands for. Autonomous Extent Store. What does this on hybrid clusters do for me?
So AES we shipped, I'm going to say a couple of years ago in round terms. It was one of our .next headlines that brought this feature called Autonomous Extent Store, which I describe it when I'm whiteboarding for a customer as metadata locality, right? So you write data in your VMs, we write metadata as the storage provider around where that data lives in the system, right? So if you wrote a megabyte of data, then our system has to record what node is storing that and on what disk, and then what other node and what other disk of the system is storing it for, like, say, RF2. Metadata locality says, hey, with AES here, what if we let the cluster not worry about all the details, right? If the node wants to move it from disk 1 to disk 2, that's a node local decision, and the rest of the cluster does not have to care about that, right? So less metadata stored globally means smaller databases, means faster performance. And then, so what this is really talking about here is now that functionality comes to hybrid nodes. So yay, it was all flash and faster nodes for a long time. So now even your SSD plus spinning disk systems get to benefit from that enhanced performance as well.
Harvey, comments?
Nope.
Harvey's a fan.
I like it. These are like checking boxes for me right now.
All right, next section talks about storage consumption reporting improvements. Probably pretty straightforward, but Jair, give us what this does and what it means for
Yeah,
admin.
totally beefing up the storage widget there on the Prism dashboard. Biggest one I love here is showing the snapshot usage versus actual data storage usage, right? So more details, more at your fingertips, easier to use, good stuff.
Harvey, can you think of a time where this information would have been valuable that you didn't have?
Yes. Literally exactly what you just described, where the customer was storing a bunch of snapshots and did not fully recognize why they were lacking in storage. And sometimes from a customer standpoint, you want to make sure you have, for this customer, they wanted to have a lot of backup copies because they had just emerged from a ransomware event that they did not discover for a couple weeks. And so they, one of the ways that they wanted to move forward was to make sure that they had a month's worth of snapshots to go back to, but there was no real thought given to what kind of space that would take up for them. So they started eating through a lot of space and wondering why in the world their fairly new system was not giving them the amount of storage space that they expected. And being able to see this much more easily would have saved them at least some time and heartache.
Yeah, I can think of that, or, it's more fashionable nowadays to have, like, say, 2 data centers, and you don't call them prod and DR, right? Where one is all running all the workloads, one's running none. Now you're typically more active, and you run half the things on each one. And of course, it's still the case that if you can do application level availability, that's always better than infrastructure level availability. Like Active Directory does application level availability. Mm-hmm. With that, right, if I had a cluster that was running some VMs, but also receiving replicas of other VMs from other sites, this would be immediately useful to say, here's what the cluster is consuming locally for its own VMs. Maybe it's replicating those elsewhere, and then other VMs are incoming via replication. What's the space breakdown between those two kinds of buckets of data?
Yes.
Is it fair to say this data was available, but at a lower level, somewhere in a shell somewhere versus in the UI?
Yep, totally. So
yes,
bringing it more up to the surface and easily reportable.
I mean, it may or may not have happened, but way back in the day, I might have been able to find this stuff through a CLI, but I just started deleting snapshots until I saw the desired result. That might have happened. I don't know.
I mean, between that and Andy just letting them rip with memory overconsumption, Harvey, I'm hearing you need to double check some of Andy's configs.
They haven't let me out of the lab scenario in a long time, so it's okay. All right, enhanced virtual networking. The first thing I saw when I glanced down was this 3-letter acronym VPN. What's this thing all about, this subnet extension piece? So
VPN, or, oh yeah, right. And then also really VPCs as well. So like virtual private clouds. So with this now, with the flow networking, you can extend your subnets across sites now, which is very exciting. So that you can now have a software-defined subnet that you see it as spanning both of these 2 data centers. In reality, that you have no network hardware supporting that, right? All done in software.
Yeah, I could see this being very valuable. Is there any type of latency requirement, some millisecond to do this, or is it doesn't matter?
I don't have the chapter and verse memorized on that one. I assume laws of physics still apply. So if you have bad latency, you will probably not have a great day turning this on.
Yeah. But you talked a while ago about having, active data centers and workloads in both places. And
Totally.
I guess you could have application performance issues, but in general, your data center just logically became two places.
100%. Yeah. I mean, good software-defined networking is built on a foundation of good hardware-defined networking, right? So thou shalt have good latency and throughput, and then you'll have a great experience using a software-defined overlay on top of that for ease of management and mobility.
Which Gyra commandment was that? Thou shalt have good latency.
We'll call it number one. have a good network.
Yeah, it was funny. I was in Cancun last week. Couldn't communicate with anybody. I tried every app I could think of. A friend of mine recommended I use, WhatsApp. He's like, "Oh, my European friends." You're like, "Yeah, but if I have bad networking, it doesn't matter what app I'm using." It was funny. I'm not a non-technical person. Thought they had the answer. Like, look, if you got bad network, you got bad network. You can't do much about it.
That's like not having enough memory earlier.
Wait, Harvey, it sounds like you're saying I can't just go download more memory. I don't understand.
Yeah, no.
All right, multiple external networks is a call out here. How's that as a subset of enhanced virtual networking?
Yeah, the example given here I think is super neat, where within a VPC, right, we could define different rules to say when this virtual machine wants to go talk to an internal service like Active Directory, don't NAT to go do that. When I do want to go out to the internet or perhaps other targets, do use a NAT for that traffic flow. So more control, more flexibility for the way your apps need to behave.
And this is all relative to building these clouds within a cloud concept.
Right. Yeah. Fundamentally, right. How do we help, IT teams open up their app store or their hosting ability for their internal teams to go and deploy apps without needing to do sort of hard fixed allocation on real networks on real switches every single time, right? If you can do that in software, if I could have overlapping subnets, right, which is very crucial for like hosting providers, all these problems that we have to solve that are more easily solved in software than they are in hardware.
Right. Next section here says simplified management and automation. The first subsection says VM templates for AHV. Is this something that AHV is catching up with the rest of the guys in terms of template management process?
I think it even brings a couple of new tricks up its sleeve as well. This is the feature I'd say for sure. Hop into the test drive environment, kick the tires on it, see what you can do. Because one of the really neat tricks is the ability to version your templates, right? So I can, like going back to like an EUC environment, I can say this is my February 2022 template, and then I can go and deploy 100 VMs from that, 200 VMs from that. Next month I power it on, I apply my updates and security patches, and I check that back into the library as the March 2022 template, right? So that concept of versioning templates and flagging them for availability internally for consumption, I think is really, really slick.
Harvey, I know you've got history, tons of history with VMs and templates and rolling out from templates, and this, where does this fit in your?
Well, I mean, just makes the process easier. This is a new set of features, kind of what Gyra was just talking about, that we can use to help with some future OS deployments that are outside of the purview of other imaging type software. This is something that is built in, that you no longer have to either go create a process yourself or go use some other third-party tool to help you make this happen.
Next section talks about multi-node removal.
So to paint a word picture here, if I had, say, an 8-node cluster and I wanted to eject 3 of those nodes, to go send them on an away mission to start a new cluster for a new purpose, right? The ability to grow clusters, shrink clusters, long-standing Nutanix value prop that you can grow and shrink as your needs change. If I wanted to eject those 3 nodes before now, I would eject node 8 and then node 7 and then node 6. And when I ejected node 8, right, I've got data on there that I need to move elsewhere in the cluster so that node 8 becomes empty and I can walk away with it, right?
Yeah.
So you could potentially imagine that I might have moved the same bits from node 8 to node 7 to node 6 and then to somewhere else in the cluster like 4 times, kind of wasted work there. So now with this enhancement, you can tell it that you can remove multiple at a time, and it also doesn't therefore cause itself any rework there to shuffle those bits over and over and over again.
And I'm assuming obviously that it does the math and makes sure that that's safe to remove all those. I mean, if it didn't, it wouldn't be in here. But I mean, this seems very useful because more than likely when you're sizing down a cluster, you're probably going to do more than one node if you're retiring some older stuff or moving stuff around.
Totally right. I mean, it's applicable to what's now a reality for our customers, right? That have been with us for long enough now on their server virtualization workloads. If you have let's say an 8-node cluster, running your data center, maybe you bring in the latest, hottest Intel or AMD CPUs. Maybe you need 6 nodes now. We've said for years, but now it's finally a reality for you. That's like the easiest upgrade you don't have to do at all. You just add those 6 nodes to your cluster. For like 3 days, you're running a 14-node cluster. And then what you would have used to have to do is just, one week, just go in and inject a node every day, right? Just eject every day with your coffee. You're just ejecting a different node. Yeah. And eventually you're down to those 6 new nodes. Now that's 1 click for you instead of 8 clicks to eject those 8 old nodes.
Right. Every time I have that conversation, I think about the 2 or 3 times I retired a SAN in my career and the joys of rolling that thing out the door, which was joy. Also the fact that sometimes it didn't fit out the door or in the elevator and you're going, how in the heck did they get it up here? I don't get it. Or down here. All right. Next section talks about storage container management in Prism Central. What's this?
Yeah, so bringing more of what's traditionally been a Prism element function up into Prism Central, making it therefore under the purview of PC, RBAC and role-based control, and also just centralizing, right? So I can now see all my containers across all my clusters in one spot.
I missed the opportunity to talk about the CRUD acronym.
Yeah.
That one's non-compliant. It's a 4-letter acronym. So.
Maybe it deserves to be. Harvey, give me your best attempt at explaining why this matters.
That's
all right. We'll move to the next topic. No, I'm just kidding.
So I think, and I guess Jerry, you correct me if I'm wrong here. I think this is necessary because we've got a lot of things that are moving to Prism centrally managed instead of Prism element direct on the node, and this is just helping move into that direction a little easier.
Yeah, I'd call it a convenience enhancement, right? Like bring more of the functionality into the browser tab you're already logged into.
Yeah.
All right, enhance maintenance mode. How much can we enhance the maintenance mode?
So another one that historically has been kind of a CLI operation now is in the GUI there, but also bring some new tricks to it that when you say, I need to, add more memory to these nodes because we tried overcommit and we want to go back to adding more memory to the nodes. Then when I take that node into maintenance mode and then I take it down and add DIMMs to it and then bring it back up, it also remembers where those VMs lived and then moves those VMs back onto the node that they belong onto, or belong in air quotes there, to restore data locality, right? So that we don't have to chase them around within the cluster to relocalize more data.
And just another example of intelligence and efficiencies through, continuing to evolve the software.
Mm-hmm.
XPlay enhancements.
So XPlay, not a household name just yet, really deserves to be. Our low code, no code automation done right within Prism Central. So if you want to chain together a bunch of actions like on Friday at 10 p.m., take this VM down, maybe grow the hard drive or add some memory to that virtual machine, power it back up, send me a Teams message or Slack message or maybe a WhatsApp if you want to, call some APIs there. Let me know that you did it right, or email the application owner to say, I've completed your change request for your virtual machine, a CRUD request, if you will. That's all existed natively within Prism Central. So we're making that functionality smarter here with new things that it can do. So adding here some lookup actions where we can look up this as a cluster, a host, or a virtual machine. So if that provides all kinds of extensibility for, like, if you had a random IP address, you can now call a playbook to say, look up this IP address, find the matching virtual machine, and then send me back the VM name or convert it somehow. But then also more fun, send those alerts. Like I said, Slack, Teams, if you know the WhatsApp API, you could probably code that yourself. Now natively send to PagerDuty, right? So for your ops teams, that want to get alerts perhaps that match a certain level of severity, right? If it's the red klaxon alert, then I want to get that on my phone via PagerDuty. That's a native integration now.
You guys didn't tell me we were going to talk about automation.
Sorry, trigger warning for Andy.
I was going to bring that up. First, you allow them to overcommit memory. Now you give them an automated task to shut a machine down and just add memory.
Well, the way I describe that to admins is like, if it's a VM that you need to do something on, add CPU, add memory, whatever, add a new disk. And they're like, you can only do it during a maintenance window, and it's only Fridays at 10. Well, you could simply be awake Friday at 10 on the laptop on the VPN and make the change. Or I would rather, do that Thursday morning at 9 in the morning, program all the changes, use a repeatable runbook for that, and set a trigger based on time to say, hey, at 10 p.m. when you automated system are awake, you go do this for me, and just email me if there's any problems with it. Otherwise, don't bug me.
Yeah, you guys, like, if I was still running the world, you'd have to like crank the thing on the front of the car to start it. Imagine how much bonding between husband and wife that created.
Oh my gosh, I'd rather not.
No, I'm just kidding. I've gotten used to punching the button. Well, like always, it's pretty simple to go kick the tires with this thing called test drive. I assume it's ready, and well, there it is, says it right there, test drive today. So everything we've talked about here can be played with in a matter of moments just by going out to the Nutanix test drive site.
Yeah, I think it's super exciting. It's a mix of major and more visible and less visible enhancements, right? Kind of a mixed bag there, very well rounded. But throughout it all, the key is just software that makes your infrastructure get better over time, right? So like your Nutanix cluster does more for you tomorrow than it did yesterday, and runs better, runs faster over time. I think that's just the coolest thing ever.
Well, and for people that have been around me lately, I'm constantly talking about digital transformation, what phase you're in, because it's never ending. And because XenTegra is who XenTegra is, we're always talking about digital workspace, front-ending that digital transformation. Jaira, I was doing that to you when Harvey jumped on a while ago. I was showing you our workspace, right? You've got this amazing digital transformation thing happening in Nutanix. I would argue that your digital workspace that front ends it isn't, I mean, maybe you have another one I didn't see, but the one that I saw was very lacking in terms of all the things that could be leveraged for to go along with that digital transformation.
We definitely have different whiz bangs, don't we?
Yeah.
So Jaira, you did all this in a weekend, huh? You deserve yourself a raise. That looks like a fancy chair. Give yourself
thanks, buddy.
A couple inches.
We had a long weekend last weekend.
All right, guys. Well, we're out of time. I've got another podcast to do, but I appreciate you guys joining, and we'll get this posted in the next 48 hours.
Sounds good.
Cool. Talk to y'all.
Have a good one.
Thanks.